So, my topic is state machine testing. And I don't know who of you already was in the nice situation to test a state machine and had to deal with it. I hope that that these improvements that we applied will help you in the future to make it better. Um, so basically, what we all have to agree on is that the state machine is the heart of the order management for every shop. Um, and it is, I mean, nowadays everyone talks about TDD, everything has to be well tested. But from what I think is that testing the state machine was so complex or yeah, hard to do that this got most likely only manual testing. Um, that is because of setting up writing state machine tests was complicated. I need to change the slide. It is not complicated anymore. To be able to test a state machine, you have to have some prerequisites, which is like you have to have an idea of your state machine that you want to build, basically. It's not completed, but at least the part that you want to build next. You also need to plan ahead what commands and conditions you will need in that processing part. Maybe just a side note, you know that state machines can be split in sub-processes, and you can also really look at one sub-process and make that testable. You can also make it testable when you already have your state machine. That's up to you. In general, I think this is the new approach even helps using TDD to build the state machine and the commands and conditions around. The test methods that you have in Spryker, we follow the arrange, act, assert. And also for state machine testing, that's the same thing. And what you can see here in test method arrange is the biggest part and probably also the one that takes the most time when I deal with state machine tests. And that was more or less because there are so many things that have to be connected in the background to make state machines testable. So it may be different for project developers as for core developers. When I develop something in a core module, I basically always had to have a surrounding project where the state machine is defined and where all these sub-processes are defined. And these, I need to have all commands and conditions um, available in the core package. And yeah, to that was very complicated. But with the new system, that's more easy, specifically also for core development. But for project, it's the same. You can have isolated tests more easily. Um, then the act part is probably the simplest one, where you just do something and in the end you assert that an order item is moved to a state that you expect or not. This is what you then assert. Um, from my perspective, the target test method structure should be like this. So you have your test method. Um, the method names are a topic that is highly discussed all the time when I talk about test method names and very influenced by everyone with different opinions. So don't nail me down on this Gherkin syntax I try to apply. You can use whatever you want. But in the end, you have a start state is given. When something happened, then you expect this and that. And that's also in the arrange, act, assert. And from my point of view, a very good test method has exactly these three lines, not much more. But when I looked into state machine tests before this approach was applied, then already the arrange part took like 10, 15, 20, or even more lines to set up. Um, so how can we achieve that these test methods are easy to read and are simple to manage also in the future? For that, as you may know, we have lots of helpers in our system that come from the core that you can use on project level as well. And there are two, one new and one updated helpers that you can use on the project level. One is the OMS helper that is responsible for dealing with commands and conditions. And the other one is the sales OMS helper that is there to have an easier way of setting up the state machine, setting up items, and interacting with the state machines and the order items. Commands and conditions can be added in two ways. One is by codeception configuration. You have them, you saw them already on project level where you have these modules enabled, and there you can add helpers, and helpers have the option to be configurable. Um, I will come to that in a minute. Just between that, commands and conditions need to be a bit defined here. Um, Commands are there to trigger specific actions, like sending an email, and they are executed when a status is entered. So when you have two states, state A, state B, and you have a command attached to state B, when state B is reached from the order item, then this command will be executed. And conditions are run between states, and they are there to make decisions. You can also say that's an if-else branch somewhere in your code. Um, we also added a way to have mocks for those, and we also deliver some, let's say, default usable mocks that you can also use in your codeception configuration. It's command by item plugin mock, by order plugin mock, and then we have for the conditions always true and always false conditions that can be used to set up your test in a more easy way. Because you may want to test that a condition, no matter where it is, that the always true case, it always returns true no matter what the other things are around doing, or always false. It depends on the case that you or your transitions and the state machine you want to test. How you can use the command and condition mocks, as I said, one point is in the codeception configuration, where you have these modules enabled, and when you have the OMS helper, you have the key conditions where you put then the name of the condition, which is the same as defined in your state machine XML, and a fully qualified class name to the command that you want to test, or the command mock, same for conditions. Um, what is important to note here is that when you add commands and conditions via codeception to your test, to the module under test, then these are added for all tests. So basically, you could also um, group or better arrange your tests for that contain certain commands and conditions and group them in one module and test those specifically. But there is also a bit more flexible way of using a helper method directly in your test case. And those commands or conditions are then added for just this single test case. The configuration is basically the same. You add it via the command or condition name that you have in the state machine XML file and the fully qualified class name, but you do that here just in code when you need that. Then to be able to test, you have to set up the test state or the state machine. And the goal for me was that it should be easy to set up and that you are not bored with all these details around it, because you have to basically know that what is the state machine name that you want to test, where are these files, and the connection of this is done from testing perspective by a lot of mocks that mock configs and config classes. And this sales OMS helper takes that problem away by giving you a method to set up the state machine where you pass the name to it and a directory where you can find, or where this test can find the sub processes. And that's managed by the setup state machine method. Then one or another big task is setting up order items and the order it belongs to. So what you are interested from testing perspective is only that you can move an item from state A to state B. But in the background, this item needs to be attached to a specific order. It needs to have shipment. It needs a payment method. It needs lots of things that you're basically not really interested. You want to test the transition from state A to state B. And for that, we have a helper method, have order item in state, which encapsulates all the logic that I set to the background for you. It creates an order, it attaches the item to it, and does all the magic that is required to have a, let's say, complete and testable order. Um, this can also become, again, very complex. So when you think of that your conditions or commands need specific data in the order item, or you want to test specific data in order items, there can be many. But for that, there's also the way of using seed data that you can pass to that method, which makes it, again, a bit more complex to read. It's not just one line. But if you have such cases and you see that you repeat this item setup, then my recommendation always is to put that either into the tester class, or you create your own helpers to build certain items with the data structure that you need. So basically, it's like the seed data we use everywhere in our tests. It's the second argument here for that method. And under the hood, it's using these data builders you should also have seen already in Spryker. Then the next part is the execution, so the act of the state machine. And that's basically just one line. It's try to transition order items. And whatever you have set up in the arrange part, the order item state or the order item in state, in the end, you expect that it's moved from state A to state B. And um, behind this try to transition order items, there's also a lot of magic or code executed that you would normally have to have in your test. It loads the order items, it's checking conditions, it's moving the item when it's possible. And you can also trigger specific events when you pass the event name to this try to transition order items method. It's the same as if you would run the queue worker um, with the event name on it to run the state machine. But here it's just a single line that you need to execute, and in the end, either those are moved or not. And for that, we have the assert order item is in state method, and it's this is the simplest scenario that you can see, that you have an order item in state A, you try to transition, and then you expect it to be in item state B. And behind that, there is all these magic that I explained with setting up the order, configuring the state machine, and reading all the data when it's necessary, running the state machine, and then for assertion, loading the items and check if the state of this item is now the expected one. And by that, it's very easy to set up these test cases. What's also need to be mentioned is that for these tests, that they have to have a lot of entities in the database, like the order items, maybe states that you haven't set up, and other things like payment methods, and that will blow up your database over time when you rerun the tests and rerun and rerun. It will always create new entities in the database, and usually we have two ways for the data cleanup, and that's also integrated in these helpers already. um, One is that we have a transaction helper that you can use in your modules enabled codeception configuration. And that is basically just wrapping around everything with a transaction. So after the test is executed, it's rolled back and your database should be in the state as before. And the other way is using data cleanup helper, which is, as I said, also included in the new and updated helpers. Those are basically whenever an entity is created, they create a callback, which is used after the test is executed to clean up the database, to remove all these unnecessary data from the database again.